Okay, ladies and gentlemen, this is just a quick follow-up video. Some of you may watch it, some people may not. What I'm going to do is I'm just going to review quickly how to work these out so the Ed puzzle video wasn't so long. So very quickly, we want to take a look and say, well, if we want to draw these compounds, we know that we have an Si, a silicon, right? And we know that we have a chlorine, and we have 4 chlorines. So a couple of things, we want to follow the octet rule, which means that all atoms want to have 8 valence electrons, because we're talking about these right here, these non-metals are the ones we're talking about. Hydrogen's always going to go on the outside. And remember that the hydrogen's going to have just 2 valence electrons, the hydrogen is. And then if you see something, the most different ones are pretty much always going to go in the middle. So there's a P and 3 Fs. The one that's the least amount would be the P. So P would go in the middle. All right. And carbons always are going to be going in the middle. So let me get you started so that we can, let me keep track of my time here to make sure I don't go too far. So if we start off, we're going to say, okay, let's draw this thing out. We have silicon, and silicon has 1, 2, 3, 4 valence electrons. So silicon has 1, 2, 3, 4 valence electrons. And then we have chlorine. And we know that this chlorine, I'm going to make it a cursive L. This chlorine is going to be over here. Here's our chlorine. Here's our chlorine. And then we're going to draw it so that we know bonding has to occur because the chlorine has to bond to that silicon. So chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And now this becomes a game to say, okay, well, what do I need to do to get this thing bonded? So in this case, what we're going to do is say each one of these atoms needs 8 electrons. Chlorine right now only has 7. So chlorine needs 1 more, but they're not going to take it, they're going to share. So the chlorine is going to share that electron with silicon. And now chlorine has 2, 4, 6, 8. This chlorine is going to share with that electron. This chlorine is going to share with this electron. This chlorine is going to share with this electron. And now we're done. So this compound would be, right? Silicon, 1, 2, 3, 4, 5, 6, 7, 8, because silicon is also sharing. Let me change that color. I'll make that one blue really fast. Silicon is using up these 8 electrons, right? Silicon's happy. And then this chlorine is using those. You don't have to draw it like that. I'm just showing you where these connections are. And that's where all of these atoms have the octet rule, okay? The chlorines have 8 and the silicon has 8. So this formula, once I would draw my stick figure, so my stick figure, ladies and gentlemen, would look like this, and it would be Si. And the silicon will be bonded to the 4 chlorines. Now, how many electrons are there in a bond? 2. And there it is right there. So this would be our stick figure. And how many bonds do we have? And what kind? We have 4 single bonds. All right, let's move on to the next one, PF3. So let's take a quick look at PF3. All right, so let's see PF3. So we have PF3, we have it right here. So we've got a P, and P is right over here. Oops, there's our P. How many valence electrons does it have? 1, 2, 3, 4, 5. All right, so the phosphorus has 5 valence electrons. 1, 2, 3, 4, 5. All right, let me make those a little bigger for you. 1, 2, 3, 4, 5. And then we're going to be going around the outside with an F. So fluorine, which is over here, has 7 valence electrons. So that's going to be our F will be here. And then we'll have an F here, and we'll have an F here. Now, Mr. P, how come you didn't put the F on the top? Well, P already has 2 electrons here. All right. So fluorine, if we look, needs how many electrons? Just 1, which means we're going to put it in a location where only one electron is needed, right? And just like we did last class, we're going to have this thing all filled out, right? So then we're going to have fluorine has 7, now has 8 because 2, 4, 6, 8. This fluorine now has 8 because 2, 4, 6, 8. 2, 4, 6, 7. Borrow or share one more. Now fluorine has 8. What about the phosphorus? Well, the phosphorus, if we take a look, the phosphorus has all of these, 2, 4, 6, 8. So the phosphorus is an octet. Fluorines are octets, and they're all set. So now what we're going to do, let's take a look at this next one. Now, when we look at these atoms, we want to make sure that we see where they are in the sense of what are they, where are they? So this one says N2H2, right? Now, oh my goodness, sorry, I'm killing your time. N2H2. So remember that it says H's are always going to be on the outside. So H's are always going to be on the outside, all right? So these hydrogens can only be bonded to one thing because remember, hydrogen is coming in with 1 valence electron. Hydrogen only wants to have 2 valence electrons. So we'll take any other element, we can only have 1 bond here, which means hydrogen's never going to be in the middle because it can't bond to more than one thing. But this X, or whatever this imaginary element is, it could bond to a bunch of different stuff. So hydrogens are always going to be on the outside. So in this case, we have to kind of play a game and say, how is this going to work? All of these atoms have to be connected. So we kind of sometimes just have to start drawing, and we're like, okay, there'd be a nitrogen. Okay, probably these 2 nitrogens are connected. And the 2 hydrogens, when you see it set up like this, believe it or not, these things are usually going to be symmetrical, which means they'll be the same on both, if that's possible. All right. So hydrogen is coming in with 1 valence electron. Nitrogen is coming in with 5 valence electrons, 1, 2, 3, 4, 5. So they're coming in with 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So starting off here, hydrogen wants to have 2 electrons total. Nitrogen wants an octet. Right now, nitrogen has 2, 4, 5, right? When hydrogen and nitrogen share, nitrogen now has 2, 4, 6. This hydrogen also will have 2, 4, 6, but the nitrogen's not happy right now. Hydrogen only has 6 electrons. Hydrogen wants to have 8. But sorry, if I said hydrogen, I meant nitrogen. Nitrogen has 6 electrons, but nitrogen needs to have 8. So nitrogen's going to have to share more. Now remember, these nitrogens are going to have to connect to each other. So this nitrogen is going to come in this way. And if we look and we'll pay attention to the nitrogen on the left, this nitrogen has 1, 2, 3, 4, 5, 6, 7 electrons. Almost has 8. And this nitrogen over here has 1, 2, 3, 4, 5, 6, 7 as well. So each of these nitrogens need to come on in and share again. So if we were going to draw this figure, ladies and gentlemen, I'm working at 10 minutes right now. This would be, this would be nitrogen, nitrogen, and hydrogen. And wherever we're sharing electrons, that's going to be a bond. So that's worth 2 electrons. That's going to be a bond worth 2 electrons. And then we have 1, 2 bonds here. And those are our 4 electrons. And you can see there is an extra pair up here at the top on each one. So there we'd have 2, 4, 6, 8, 2, 4, 6, 8. Eventually, we will be showing those dots up there. But right now, I'm not having you show those little pairs of electrons. All right? So this would be our answer. What would we have here? We would have how many single bonds? 1, 2 single bonds. So 2 single bonds. And then we'd have 1 double bond. 1 double bond. All right? So this becomes kind of a game to try to get everybody to 8, and they can get super complicated. So this will be the last one. So if you see something where it's like C5H12, this is a hydrocarbon, hydrogen, carbon. And that means that this is going to be a big, long carbon chain, kind of like the fat or the sugars that you saw in your biology class. This is what we're going to start learning about. That means all these carbons are going to be connected in the middle. So when we see this set up like this, you'll see that the carbons are going to have to be connected, and then everything else is going to be kind of floating around on the outside. So let's draw this thing. So there's a carbon, there's another carbon, and then we're going to have a hydrogen. We have 2 hydrogens on this carbon, and each hydrogen comes in with 1 valence electron. I'm going to put it here. I'm going to put this carbon down here for no other reason than it's too close to that, okay? So I'm going to give myself some more space. Each carbon is coming in with 1, 2, 3, 4 valence electrons. 1, 2, 3, 4 valence electrons. 1, 2, 3, 4 valence electrons. And we want to make hydrogens happy. So let's make the hydrogens happy. How could we do that? Well, hydrogen needs 2 electrons. Hydrogen needs 2 electrons. So the hydrogens are sharing. These hydrogens are going to be sharing here. These hydrogens are going to be sharing here. And let's just take a look at our carbon. This carbon now has 1, 2, 3, 4, 5, 6. Is this carbon happy? No, this carbon is not happy because there's only 6 electrons. But if we share, now let's take a look at how many electrons there are. 1, 2, 3, 4, 5, 6, 7. What are we going to do? 1, 2, 3, 4, 5, 6, 7. We're going to have to share again. So then these electrons here are going to have to share. All right. Now I'll show you a better picture, and I won't make you wait for it. So what I just did is I just redrew this, because after you do one of these problems, you can be like, man, I could have set this up a lot better. So you can see we still have 2 hydrogens attached to this carbon, 2 hydrogens attached to this carbon. But you see how we do this, like this little jangly, it's kind of janky, right? So what we want to do is we want to get this thing organized a little better. So we're going to say, okay, well, there and there we have our hydrogen set up. Here we have our hydrogen set up. All right, now you can say, oh, look, our electrons are set up much better to each other. So even though I was like, oh, I kind of ran out of space, it wasn't the best way to go, because there's a better way to make it more organized. So if we come in here, you can see 2, 4, 6, 7. But if we share here, this would be 2, 4, 6, 8. Now, what would this look like? If we were going to draw the stick model, I'm going to draw it right over here. Ready? Make that bigger. There we go. So I'm going to draw the, oopsie daisy, I didn't want to do that. Sorry, I had to bring in a blank piece of paper here so we can see a little blank canvas. So if we're going to draw this out, then this would look like this. We'd say there's a C, and it's attached to a hydrogen. It's attached to a hydrogen. And then it looks like those are bonded right there to another hydrogen and another hydrogen. But you can't forget about this one here. And there that is. So we have 2, 4, 6, 8 electrons, 2, 4, 6, 8 electrons. This would be our structure. And we would have how many single bonds? Yeah, we would have 4 single bonds. And how many double bonds would we have? Yes, we would have 1 double bond. Even though you're like, wait, but there's 2. Yeah, but this is 1 double bond. All right. So, ladies and gentlemen, I hope this video was helpful. It was 15 minutes. And that's it. Just showing you how to do a couple more of these.